A glimmer from the stars. Could we be seeing alien lights? Intro. The James Webb Space Telescope has recently made a discovery that has stunned astronomers and captivated imaginations worldwide. It captured what appeared to be glowing lights, regular and rhythmic, almost as if they were emanating from a city, shining from a point roughly 4 light-years away. This extraordinary finding has rekindled one of humanity's oldest and most thrilling questions. Are we alone in the universe? These mysterious lights were observed on Proxima Centauri b, an exoplanet that orbits the red dwarf star Proxima Centauri, the closest known star to our solar system. What makes this discovery even more remarkable is that Proxima b lies within its star's habitable zone, the narrow region where conditions might support liquid water, and possibly life. The telescope's sensors picked up bright, flashing signals that seemed to appear from the planet's night side. Could these be a natural phenomenon we've never encountered before? Or is it possible they're evidence of something artificial, maybe even intelligent? Reigniting the search for life beyond Earth. For as long as humans have gazed at the night sky, we've wondered about life beyond our blue planet. We've written stories, filmed movies, and conducted countless scientific investigations, hoping for some indication that we're not alone. Now, thanks to the cutting-edge capabilities of the James Webb Space Telescope, this long-standing curiosity has been reignited with new energy. While past efforts have yielded only speculative clues, this is different. This is real data, gathered using advanced infrared sensors from one of the most powerful space-based instruments ever created. The lights observed on Proxima b closely resemble the light pollution patterns we see from Earth's cities when viewed from orbit, regularly spaced, consistent in brightness, and too structured to be random. Naturally, this has set off a wave of excitement, cautious optimism, and rigorous scientific inquiry. Astronomers around the world are now reanalyzing archived data and recalibrating their instruments to get a clearer picture of what's happening on this alien world. If these lights are real and artificial, they may represent the first techno-signature, evidence of technology, from an extraterrestrial civilization. Understanding the planet. What makes Proxima b unique? But before we jump to conclusions, we must understand the nature of Proxima Centauri b. This rocky planet is about 1.17 times the mass of Earth, making it a terrestrial planet like ours. However, it orbits very close to its star, completing one full revolution every 11.2 Earth days. Because of this tight orbit, Proxima b is likely tidally locked, meaning one side always faces the star in perpetual daylight, while the other is plunged into permanent night. This creates a stark contrast in temperature and environment between the two hemispheres. If the planet has no atmosphere, the differences between the day and night sides would be extreme, scorching on one side, freezing on the other. But if Proxima b has a thick enough atmosphere, it could redistribute heat and allow for more stable conditions, potentially supporting liquid water and, by extension, life. According to Dr. David Kipping from Columbia University, this planet behaves unusually for a rocky body. Unlike Earth-like planets that mostly absorb and re-emit solar energy as infrared radiation, Proxima b exhibits thermal patterns that don't quite match our expectations. That's one reason why the lights stand out. They don't behave like reflected sunlight or natural heat emissions. Infrared vision. How the James Webb Telescope detected the lights. The key to detecting these signals lies in the James Webb Space Telescope's advanced infrared imaging capabilities. This telescope can observe heat signatures, chemical compositions, and light variations with astonishing sensitivity, even from multiple light-years away. While many telescopes struggle to see faint light in the vast darkness of space, James Webb is designed for exactly that. Its instruments are especially effective at spotting infrared light that might be artificial in origin, such as the narrow-band light that could be emitted by electrical grids, industrial activity, or even city lights. What's more, the telescope's orbit coincides with Proxima b's rotation in a way that allows it to track changes over time, especially across the planet's night side. This makes it one of the best tools currently available for studying planetary thermal emissions and artificial illumination, if such a thing exists. The presence of these lights, along with the unusual thermal behavior of the planet, raises profound questions. Could this be evidence of an intelligent species using energy? Could it be a reflection of an entire civilization, quietly glowing in the cold silence of deep space? The science behind the signal. Recap. Previously, we explored how the James Webb Space Telescope detected mysterious city-like lights on Proxima Centauri b. These lights have sparked enormous interest, and possibly the most compelling sign yet of intelligent life beyond Earth. Now, let's dig into how scientists investigate such claims, what makes this planet special, and what tools we'll use next in the search for answers. Thermal emissions and planetary clues. Unlike Earth, where an atmosphere regulates temperature and protects life, Proxima b's conditions may be far more volatile. If it lacks an atmosphere, its surface could swing between blistering heat during the day and freezing cold at night. The James Webb Telescope is designed to detect thermal emissions, essentially, the heat a planet gives off, and analyze how it changes over time. The brightness and temperature differences between the planet's day and night sides can tell scientists whether an atmosphere exists, and if it does, what it might be made of. The chemical search for life. The next step is to determine the chemical composition of Proxima b's potential atmosphere. This involves analyzing starlight as it passes through the planet's atmosphere during transits. Certain gases absorb specific wavelengths of light, and by studying those patterns, astronomers can tell what chemicals are present. Key biosignatures include oxygen, methane, ozone, and water vapor. If these are found together, especially in the right ratios, it could indicate the presence of life. While the James Webb Telescope isn't optimized to detect all of these, especially free oxygen, it excels at spotting water vapor, carbon dioxide, and methane. What future telescopes will bring? The James Webb Telescope is just the beginning. In 2028, the Extremely Large Telescope, ELT, will come online, using ground-based observations to study exoplanets like never before. This telescope will give us much more precise data about planetary atmospheres, helping confirm or rule out the possibility of life. Even more advanced technologies are being developed, including starlight blocking systems that allow telescopes to see exoplanets more clearly. How we'll see the invisible. One method is the coronagraph, a device inside telescopes that blocks a star's light, allowing the dim glow of orbiting planets to be detected. Another is the starshade, a large, flower-shaped spacecraft that aligns perfectly with the telescope to block starlight before it ever enters the lens. These systems could let us image exoplanets directly, even map their surfaces, and study their climates, something unthinkable just a few years ago. However, they require incredible precision, down to fractions of a millimeter, over vast distances in space. Why this matters? If we can observe the right combinations of atmospheric gases, or even detect artificial light emissions, it may be the strongest evidence of alien life ever discovered. We could learn not only whether we're alone in the universe, but what other intelligent lifeforms might look like, how they live, and how they've adapted to alien environments. This would be one of the greatest scientific breakthroughs in human history. Closing thoughts. The James Webb Telescope has opened a window into a new era of discovery. With more powerful instruments coming soon, we may be standing at the threshold of answering one of humanity's oldest questions. Are we truly alone in the universe? Each data point, each light flash, each planetary spectrum brings us closer to the truth. And maybe, just maybe, we're about to make first contact with something extraordinary.